I want to clear up possible misconceptions about scale positive weight. So, really, it's not something that you should be fine tuning. I did so in the videos just to see what would happen, and I do stand by that. I think that's one of the best ways to really learn about what you can do with hyperparameters. You fine tune them and see what you get. And the results revealed that, you know, it was doing kind of the flip of an imbalanced data set, which is, predicting, oh, everything's like an exoplanet almost. And that's what scale positive weight will do. It can both balance and imbalance the data set. So the idea would really be to properly balance it. If you look at the actual, say here the Y value counts, say, Y train and Y have the same percentage in effect. But if I look at the Y value counts, so using the 250 rows, 37 are exoplanets. And, that's a little imbalanced. It's not crazy. But in the full data set, it's much larger. And so to get the proper weight, what you want to do is you want to basically scale this number 37 up so that it's equal to 213, because that will then balance out the data. So the way you do that, here's some code for it. This just means y, okay, such that y is equivalent to 0. So that's going to give you all of those, say, rows, and the count of them will be the 213. And then you divide that by all the y's such that y is equivalent to 1, the count of those, and that will be 37. So in effect, what you're doing is you're multiplying, see, you're doing this, you're taking 37, okay, that's kind of like the row 1, label 1, times 213 divided by 37. And so then the 37s cancel out, and you actually end up with a weight so that it's also equivalent to the 213. So, weights, you could say y values, so they're equal. I mean, they're not equal, so they have equal weights. And this is the goal, that you set it equal to 37. I'm sorry, 213. I mean, you can change. The reason why, of course, I put it like this and don't write 213 divided by 37 is because, oh, there's one other thing. You may need to make it an integer. I guess I didn't need to, but you could have like 2,000 rows and you're going to get different results. So I did actually, play around with it a little bit, and here's what I can tell you. So basically, it does, do a little different fine tuning. If you look down, I'll show you the best results I got with 250 just from using similar fine tuning. So you can go through and do the grid searches again, and I think this was wasn't as strong, but I get about 55% here. And when I put that in, which is basically changing the learning rate, max depth, along with n estimators, then it did give a 67% recall accuracy. And so the idea there would be that, well, look, of the 9 exoplanets that it was trying to find, it found 6 of them, right? And so, that's potentially a good thing. And, it's not terrible that, like, it's also predicted, like, 24 incorrectly. That's also not the best. But again, if you're looking at something like scientific discovery, someone may be willing to live with those modifications, okay? And what you'll find with this data set as well, that if you use the whole data set, it'll just take a long time, but it'll be different too. So this is a challenging one to try to balance with XGBoost. I guess it balances with scale pos weight, right? It's still imbalanced data. Is challenging to get kind of a strong score, I would say, but you can certainly do it with the full data set. You're going to end up with different parameters. And I don't know, I think it's a lot of fun. And the goal here really, as mentioned earlier, is to learn really techniques for both scoring and then tackling imbalanced data. Thanks.